Okay. So it says three cousins, Heather, Gina, and Jesse, were sitting around watching football on TV. The game was really boring, so they started talking about how old they were. Heather, who is the oldest, noticed that they were all between 11 and 30. Okay. Um, so I mean, I don't know how much we can read into that, but like normally you wouldn't like give, you like want the oldest would be 30 and the youngest would be 11. Maybe we can't. We can't assume that here. Jesse noticed that the sum of their ages was 70. Okay. And Gina, the youngest, burst out, if you wrote the square of our ages, all the digits from 1 to 9 will appear exactly once, and the digits of the three squares. So how old is each person? Um, all right, so we know that I'm going to use H for Heather. The screen isn't set up for drawing yet. There, now it is. So I'm going to use H for Heather. Huh, this is an unusual thing here. Why isn't that draw? Apologize, my pen isn't syncing up. That's really bad timing for that to happen. Heather, Gina, and Jesse. I need to reset my. Are you still seeing my screen?
Yeah, I can still see it.
Okay. I gotta power this thing on and off. Hopefully that's all it takes to get to where this pencil is now working. There it is. Okay. So Heather, Gina, and Jesse. Okay. Heather is the oldest, and Gina is the youngest. So we know that their ages. We're just writing information. Um, Gina, G is less than J is less than H. Okay. It also says that they're all between 11 and 30. So we can say 11 less than G less than J less than H less than 30. The way it's written is it's unclear whether it's inclusive or not, meaning I'm not sure if 30 is the biggest they can be or if it's 29. Jesse noticed that the sum of their ages, so that's the first equation that we can write, G plus J plus H is 70. And then the square of their ages, they'll see all the digits from 1 to 9 appear exactly once in the digits of the three squares. So if it's not clear what that means, let's just say that Gina happened to be 12, for example. G squared is 144. This would not be correct because the 4 appears twice. And it says that they'll only appear once in the square of the three digits.
Oh, okay. I didn't
Okay.
understand that.
Yeah.
Yeah.
Let's just say Gina is 13. Well, 13 squared, or G squared, 13 squared is 169. That's good. Okay. Um, so there's a lot of ways we can do this. That's why I asked, like, how are you allowed to solve this? Like, are you allowed to use software? Like to me, Excel's kind of like the thing I would try right away because it gives me the ability to like play with numbers. Um, do you know what you're allowed to use or not use to solve this problem?
I don't think she cares what I use.
Okay. So I haven't had to do this in a while, but let me open up Excel and I'm going to share that with you. So I'm going to do a new share here. I'm going to send you everything. Plus, this is being recorded, so if you miss anything, I can send it at the end um, as well. So hopefully you're seeing my Excel screen now.
Yeah, I can see it.
Okay. So here is what we're gonna put the person. Let me put up here. We're gonna put the name. So we're gonna go Gina, and then Jesse, and then Heather. Let me make this a little bit bigger. I always forget that this doesn't look super great when it's zoomed there. And then we're gonna put their possible age, and then their age squared. Okay. And then there's some things we want. We want to know like the sum of their ages. Okay. Um, and we're looking for digits over and here. So let's just pick some. Let's say that Gina's 13, and let's say that Jesse is, I don't know, let's go 15. If the sum of the ages has to be 70, to get Heather's age, we take 70 and we subtract each of the other ages. Okay. So 42. Is that allowed based on what this says here?
Wait, what was that? I don't
Is
understand.
this allowed? Can Heather be 42 based on the information you have?
Uh, Let me add it.
Well, no. It's because they have to be between 11 and 30.
Oh, okay, yeah.
Okay. So this doesn't work. So for example, like this could be 17, but then that's not good enough. So I'll just pick like 25. Okay, and that still doesn't work. So let's go 27. So that does work. So now let's square each of their ages. Equals that number squared. And then I'm just going to copy this down. So we're looking for all the digits to appear, like from 1 to 9. Do you so like 1 appears, a 2 is there, but there's no 3. So this combination doesn't work as an example. Is that okay so far? Like we're kind of just guessing, checking a little bit.
Yeah,
Okay. Um, so you have to dig a little bit deeper, and you have to. I'm going to go back to sharing my screen on the on this OneNote thing. When you square certain numbers, like when you when you squared 12, you got 144, which was even. 13 seemed to be a good choice. So we need to figure out which numbers, when you square them, do you get unique numbers, unique digits, no duplicates. So like 169 is good because they're all unique numbers. Is that clear? But like
yeah.
30 squared is 900. That's bad because it's got a duplicate of 0. So we're going to go back to the Excel thing here, and we're going to look at do you still see the same thing here?
I see the Excel thing.
Okay, the Excel thing. Okay, great. So we're going to start with 11, and we're going to go up by 1 all the way to 30. Okay. And what I'm going to do here is I'm going to square each of these numbers. Okay. And if there's a duplicate, like this one is a duplicate, we know that this is bad. Okay, but let's look at the next one here. So that one is also bad, right? That one
Yeah.
is also, that one's good. So that one's good. So instead of writing all the bad ones, I'm just gonna write the good ones. So we're gonna copy this formula down. Is 196 good or bad?
Oh, that's good.
How about 225?
Bad.
Okay, and so on here. So let me grab this word. That's good, good, good. That one's good, 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 good there. Okay. Okay, so these are the only ones that we can even try. Do you agree with that? Like the ones that
Oh, what
I've
about 24?
uh, it is also good. Thank you. I didn't catch that. All the other ones have at least one duplicate
Yeah.
there. So what this does here is I'm gonna highlight the ones that we can use. And I'm gonna put them in green. Green to me is like good. Green is go kind of thing. So you start looking at them, you're like, okay, well, 169, how am I going to get a 1? I can get a 1 with 13 and 14. So it's like one or the other. All right. Um, I get a 6 and a 9, and then I need a 2. So I need one of these numbers. Or I got to grab a 2 from like 729. Do you see how I'm doing that? Like I've got to find a
Yeah.
2. Um, and then and then there's this constraint here. So it's the harder one here is going to be to figure out which of these numbers do you get that ends up working here where um, you get all the digits. So I think what we got to do here is make a list and see which ones overlap. So like this one has a 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And then this one has a 1, a 9, and a 6. And then this one has a 2, a 5, and a 6. And this one has a 2, an 8, and a 9. Do you follow what I'm doing here?
Yeah.
And we're going to eventually see which ones might give us an overlap here. 3, 24. So that one's pretty good because it gives you like the middle numbers right next to each other. 3, 6, and a 1. And then this one's 5, 5, 2. I'm going to send you all this too when we're done, so you'll have all of this available. 5, 6, 7, 5, 7, and 6. And then 6. And what I'm hoping here is maybe there's one that only has one of the numbers. 7. I appreciate you following along with me because it's possible that I don't get this right. So then we got 7, 84, and then 8, 41. Okay. Does that look good to you?
Yeah.
So like what I see is there's only 2 that have 3 in them. So it's one of those. And I don't know, 3 that have 4 in them. So this is going to help us kind of like check some, like guess and check a few of these. So let's say we have to use 234. We have to use the 18. How are we going to get? We need to get a 1, a 5. Let me zoom in a little bit. I don't know if you can see all this now. So we need to somehow get all these numbers worked out. So like this is just like a patterning thing. 7, 8, 9. So we got to use one of these. Are these really the only ones with 3s in them? I guess they are. So we know it's either 18 or 19, which is a good place to start. So let's go back here. So if we know that, let's just say Heather is 18, or Jesse is 18, because that's the middle age. And Heather, I'm gonna make just a guess here. Let's just say Heather is there any of one of them that don't use 2, 3, and 4? Like 1, see, there's an overlap there. 1, 4, 9, 8. Ooh, this 24 is pretty good because you get 5, 6, and 7. So then what if we go 18, 24? Let's just do the sum. Let's get the sum down here. Equals, sorry, I'm sure this is a little bit hard to follow, but it's not actually a very simple problem. So that means this person has to be 30, 28. Okay. So like this is satisfied. They add up to 70, but you don't get all the digits in here. Like we're really close, but we don't get them all. We've got 2, 3, 4, 5, 6, 7, 8, 4. We've got an overlap in the 4. So if we go down 1 or up 1, we have to get a 1. We have to get a 1. So let's go 29. And then that means this has to change to 17. So this is 1, 2, no 3 though. So that's no good either. Like we got 1, 2, but no 3, 4, 5, 6, 7, 8, 9. Eight's duplicated twice in there. So we need a 3. So that means maybe we change this to 18. 18. So that gives us 1, 2, 3, 4, 5, 6, 7, 8, but no 9. So if we go 25, what if we go 25 there? That's too old. Okay, 25, 23. 1, 2, 3, 4, 5, no 6. So what if we go 28 there and then 24 there? No, no 1 again. This is really tough. Okay. Do you have any ideas?
No, I think one of them has to be 19, right?
Probably. I mean, there's this 3 could appear here. Um, so let's say this is 19. And then 1, 2, 3, no 4. There's no 4 in this list. So 4 comes from 18. So if we go 18, that gets us a 4, but no 1. So we either go 25, nope, or we go 28, 2 sevens. So
Alright, so
if we go 18, then we got to choose the 13. So it's almost like you have to go through each of these. Okay, let's say it's 13. Well, then what's the other one have to be? What doesn't work? So it can't be either of those. Let's say it's 19. Then it can't be both of those. So then it's got to be 29, 18 and 29, and then 23. 1, 2, 3, 4, 5. That doesn't work there though. uh, so let's try this again. Let's try it with 19 now. Let's say that one's got to be 19. So we've got a 1, a 3, and a 6. We need a 5, but no overlap. So if we don't need an overlap in this, if we go 19, that's 1, 3, and 6. That means we can't choose something that's got an overlap with 1. So this 17 looks pretty good. So that gives us, but then the person's not old enough.
yeah.
So like maybe a 27. 27 gives us, and then a 23, 24. 1, 2, 3, no 4. Oh God, this is frustrating. 29. 29 gets us a 1, but that's a 1 there. So it can't be 29, but it could be any of these other ones. 27, 25. 25's got the overlap. 1, 2, 3, overlap in the 6s. Man, have you checked the internet for this one? I should have asked that first.
I did, but wait, I'll do it again because I didn't understand the question like at all before you
Okay.
explained it.
I'm going to give myself, because I'm sure there's other stuff you're going to do. I want to look at this for another 5 minutes with you, or 6 minutes before moving on. It's one of these problems that has a bunch of constraints that I just can't believe.
Yeah, we don't have to spend too long because I understand it
169,
now. Like I can do it on
196,
my own.
256. Yeah, and all of this is your time, so I don't want you to feel like you're being forced into doing that. Let me just check that these are actually correct. 567, 625, and 729, 784, 841. It's one of those that, like, as soon as you get the answer, you're gonna be like, oh, that was so obvious. Um,
In the internet, it says 19, 23, and 28.
let's take a look here. 1, 2, 3, 4, 5, 6, 7, 8, 9. There it is. It adds up to 70. And all of these digits are there. So what if I were turning this in, I would make a table of these numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9. And let me just clean this up a little bit. Um, we're bolding this, bolding. I think if you turn this sort of thing in, this will be very useful, or at least creating this on your own.
Right.
Let me snip it into the thing we're doing, just in case there's an issue with that where you can't see it. And all right, what else do you want to work on today?
It's a homework assignment.
Okay.
I don't know how to like get it to you.
Can you download and email it? Can you take a picture and email it? What any of those things work for you?
I could take a picture, but it'll have to be like 4 or 5 pictures.
That's fine.
All right. Do I take the picture with my phone or with the computer?
Whatever you're more comfortable with.
All right.
Probably whatever's faster at this point would be good. Um,
I know how to do some of these too.
we'll skip to the ones that you're not sure about, or I can give you
Okay.
more examples like the ones that you're.
Okay, I sent it. The picture's a little bad, but
I'm
it's
sure.
fine.
I'm sure they'll be fine as long as we can see their question. So checking my email here, waiting for them to come through. Are you doing all online right now with your school?
Yeah.
All right. I know that's probably not what you want. Um
Yeah, it's
it's harder to
really
learn.
annoying.
It's all right. So I see question 10, and then
Yeah, I put
8,
them.
9, 10, 6, 7, 3, 4, 5, 1. Okay. Um, where do you want me to start?
Let me check.
Number 1.
Find the
We,
coordinates.
we probably have time to go through all of these.
I think that's best then.
Okay. All right, so what I'm gonna do is snip question one into our workspace, and there's probably more of a challenge with trying to get get these entered incorrectly. All right, find the coordinates of the midpoint of segment TU with endpoints of 5, comma, -1, and 1, comma, -5. So these are ordered pairs, and there's a place that's in the middle of it. The midpoint has a formula. It's written x1 plus x2 over 2, comma, y1 plus y2 over 2. I don't find that particularly useful. I think it's better to remember it as an average of the two numbers. So if I asked you to find the average of 5 and 1, you would add them and then divide by 2. Same thing as the formula, but it's a little bit more clear, I think, when we say the words. Same thing with y1 and y2. You're going to add them and then divide by 2. So this is 6 over 2, or 3, comma, this is -6 over 2, -3. So this is what you have to enter for number 1. Any
Okay.
anything, and you've got the symbols there. You gotta grab the ordered pair. Type in -3. I'm sure there's a comma somewhere, or 3 comma -3 for that one. May I move on to number 2?
Yeah.
Okay. All right. Find the coordinates of the midpoint of segment VW with endpoints -2, comma, -6, and then x plus 2, comma, y plus 3. So it's the same deal here, except that for the second one, this whole thing, x plus 2 is x2, and this whole thing is y2. So you're still going to find the average. You're still going to use the formula for the midpoint, x1 plus x2 over 2, comma, y1 plus y2 over 2. So in this case, you're going to take -2 and you're going to add it to x plus 2 all over 2, comma, your y1 is -6, that's this value here, plus y plus 3 over 2. So there's implied parentheses in the numerator, meaning you evaluate what's on top first. So -2 plus x plus 2, these two combine to go away. They become 0. So you're just left with x over 2. This is the only thing that remains. On the right here, this -6 goes with this 3 to become -3, and the y just stays. So it's y minus 3 over 2. So all of this has to be entered for your solution to number 2.
Okay.
And I'm okay if you want to enter that now, or I can just move on to the next question.
I'll answer them later. I'm just gonna write down the answers and like how to do them, and then I'll put them in later.
Great. Number 3 says y is the midpoint of xz. Okay. All right, y is the midpoint of xz. X has coordinates 2 comma 4, y has coordinates -1 comma 1. So this time I'm actually going to draw something here. So 2 comma 4, right 2, and then up 4, 1, 2, 3, 4. So right here is x. Y is at -1 comma 1. This is y here. And it's saying that y is the midpoint. So z is somewhere down here. Because if y is in the middle, to go from x to y, I have to do the same thing to get to z. So one way to do it is to figure out like the path that you take, like you went down 1, 2, 3, and then right 1, 2, or left 1, 2, 3. You went down 3, and then right 3. So you do the same thing again. You go down 3, and then right 3. So z is right there. So we just have to figure out its ordered pair from the origin here. And then I'll show you another way to do this as well. You go left 1, 2, 3. So it's -3 comma. I'm sorry. This is the origin. 1, 2, 3, 4, -4. comma, and then it's down to -2. So let's look at another way to do this. So I write the ordered pairs 2, 4, and then the second ordered pair -1, 1. And I'm going to ask you this question. What is the jump to go from 2 to -1? How do you go from 2 to -1?
3.
You subtract 3. Okay. How do you go from 4 to 1?
Wait, you subtract 3.
Subtract 3 again. So this new ordered pair here, I have to subtract 3 from that number. So -1 subtract 3 is -4. 1 subtract 3 is -2. The same thing we got here.
Oh, okay.
So I call these jumps. But you can do or you can make the triangle, whatever you kind of prefer. Both work really well. All right, so it says find AB. Guessing it's asking for the distance from A to B. Do you recall if the distance formula was covered in this chapter section?
Yeah, I think it was. Check.
Okay.
Yeah, it was.
All right, we're going to write the ordered pairs for A and B. So A is right 2 and then up 4. So 2, 4. And then B is right 3 and then down 1. So 3, -1. And the distance formula I wrote on the left there, you need to know x1 and x2 so that we'll just arbitrarily call this x1 and y1 and then x2 and y2 down here. So I'm just going to substitute those values into the formula that I just wrote here. So the distance is, and then we're going to take x2, so it's 3 minus 2, that's x1 up here, squared, plus y2, which is -1 minus 4 squared, and then you have a square root symbol around it. 3 minus 2 is 1. 1 squared is 1. -1 minus 4 is -5. It's still in parentheses, and when you square it, you get 25. So you add these together. The distance is the square root of 26. So there's really two skills that they've been testing so far in this chapter or section: midpoint and distance formula. And you want to be able to find both of those. So if we had more time, we can certainly do more examples. I'm going to try and find 5. So 5's kind of cut off here. It says to find BC. Maybe it's the same picture for 5. Do you know?
Let me check. Yeah, it's the same picture.
Okay. So what I'm going to do is just snip in the triangle this time, and we'll do the same thing as we did in the last problem. Let me get this into our workspace. All right. All right, so we're trying to find BC. So we need to know this ordered pair. This B is at 3, -1, and C is at -2, 0. So I'm going to make this x1 and y1, x2 and y2. If you decided to change these, it would still work. You'd get the same result. So it doesn't matter which one you choose, as long as like the 1 goes with the 1 and the 2 goes with the 2.
Okay.
So write the distance formula again. When you're trying to remember these formulas, it's good to write them down each time. So I like to even have a reference sheet handy. That way I'm writing down the correct formula each time. And then I'm just taking these numbers. So -2 minus 3. Y2 is 0. I still put it. minus y1 is minus 1, so I'm going to do this. I'm going to put it in parentheses this time. So I usually substitute and show it in parentheses. That way you can distribute the sign properly in this problem. Draw the square root at the end here. Minus 2 minus 3 is minus 5, still in parentheses squared, and that does become 25. 0 minus a minus 1 becomes 1 squared. And again, if there's any if there's anything here where you're like, you don't get it, let me know. I'll cover it again. Distance is the square root of 26. It's really helpful to know the formulas to be able to do this.
Wait, wait, I'm confused.
Okay, give me a little more to it. Like, what is not? Is there a place where it started becoming unclear? I can go through it again.
Because wait, I'm trying to think about it. Okay, so you said that it doesn't matter if the x's are flipped, right? Like,
That's right. If you made this x1 and this y1 and this x2 and y2, that will give you the same result. And I'll even do it here if you'd like to see that.
yeah, because can you show that?
Absolutely. So that's here. It's x2, which is 3, minus x1 minus 2. Now notice I'm putting this in parentheses. That's critical. Because it's negative, I usually throw it in parentheses. Plus, your y2 is 0. I'm sorry, your y2 is minus 1 minus 0 squared, and then this is all square rooted. So 3 minus a minus 2 gives you 5 squared, which is 25. Minus 1 minus 0 is minus 1. It's held in parentheses because of that negative, but then when you square it, you get a positive.
Okay.
So these things, when you square them, these are always going to be positive. Like, you never subtract here, it's always plus. So this is the square root of 26.
I get it.
Great. 6. Oh, we got to find CA. Shocker. They should have just said find all the links of all the sites. uh, all right. Let me grab a new snip here. All right. So I'm going to write the ordered pairs again. This is 2 comma 4. C is minus 2 comma 0. Which one do you want to be x1? The 2 or the minus 2?
The two.
The 2. So that's x1, y1, x2, y2. So I'll write the formula this time. I want you to try on your own to get the result. And if you don't get it, I'll still work through it. But let's give at least a short attempt here. Give a minute and see if you can find the value.
Okay. Messed up.
All right. Did you get this far?
Yeah.
Great. So minus 2 is minus 4. It's not 0. They're both negative. That's 16. And then here it's minus 4 squared, so that's also 16. These are always positive. This right here reduces. It's sort of a separate skill here to be able to do this. Maybe you have seen a factor tree in previous classes. Not sure, but I'll just write the result here. It's 2 times 2 square root of 2, which is 4 root 2. It's not really a skill they're emphasizing in this particular class.
Understand what you just did right there.
Okay, 7. Okay, so name a pair of congruent segments. All right. What we should have done, or what I should have done, is left them labeled on the picture. So I'm going to snip in the picture here. All right, and so this one, the AB is what we found first. That was the square root of 26. It's the square root of 26. Then we did BC. It was also the square root of 26. And then AC was 4 square root 2. Okay, is that okay?
Yeah,
So which two are the same?
the A, B, and B, C.
So AB is, and they use this symbol with the little squiggly on top, is congruent to BC. You can, I'm sure there's some way that they want you to enter that.
Let me check. I don't know how. I don't know how I'm gonna do that. I think I can just write the two because it doesn't give me all the like options.
Yeah, you might write like AB, comma BC, like that.
Yeah.
The more a lot of so college students are used to doing these online programs, and a lot of them, like the half of it's just figuring out like how to enter the answer so that you get credit because there's nobody there except the computer to grade it. So let me know when you're ready for us to move on to number 8.
I'm ready.
All right, so distance formula, it says use the distance formula, like they're telling you, okay, we got to use it. X1, Y1, X2, comma, Y2. So the distance formula again is X2 minus X1 squared plus Y2 minus Y1 squared, and all of that square rooted. The reason it says to the nearest tenth is because we're going to have to end up putting into the calculator. So we're gonna get it down to a single number and then put that into the calculator. So this is minus 2 minus a minus 7. Y2 is 0 minus Y1, which is minus 4. Minus 2 minus a minus 7 is really minus 2 plus 7. And then you square that, so that's 5 squared, which is 25. 0 minus a minus 4 is 4. Square that. That gets you down to 16. So we're going to add these together. The distance is the square root of 41. This is not a known value, which is why the problem here says to put it into the calculator. So square root of 41. You can do this on your phone if you got that handy. 6.4 is what it looks like. I think it's at around to the nearest tenth. So if you can't tell, they're really emphasizing the distance formula. It's like, do it again, do it again, do it again. So question 9. All right. Question 9. Are you still with me, Maddox?
Yeah.
Cool. It says to use the Pythagorean theorem, but the Pythagorean theorem and the distance formula are exactly the same. So I would tell you to just use the distance formula because you have done a bunch of problems like it, and you will have more comfort using it. So this is x1, this is y1, this is x2, and this is y2. Uh, Another good opportunity for you to test yourself. What I'm going to do is just give you the answer,
Okay.
and I'd like you to try and work it out. I'll wait 30 seconds, and then I'll go ahead and put the answer in, because I know you need that for this assignment, but I want to make sure we also get through all the problems here too. All right, so the answer ends up being 11.4. This ends up being 11 squared, or minus 11 squared, which is 121. This becomes minus 3 squared, which is 9. So it ends up being the square root of 130. All right. 10 does not show a question in the picture you sent me. It just shows the side pocket.
Oh,
Oh, nope. I take that back.
okay.
I do see it here now. Sorry. When you take pictures, they don't always come in order when you email them. They just come in whatever order the algorithm decides. Okay. Uh, all right. So snooker is a kind of billiard played on a 6 foot by 12-foot table. These side pockets are halfway down the rails. Nobody plays snooker anymore that I've ever met. It's like one of those games that I mean, can't believe it's in the textbook, but it is. Find the distance to the nearest tenth of a foot diagonally across the table from pocket to pocket. So what they're asking for is this distance across the diagonal, the hypotenuse of this triangle. So it's essentially this. This is 6, this is 12, and they want to know this diagonal here. Had in your notes, you likely learned the Pythagorean theorem.
Yeah.
So it says A and B are the legs, they're the shorter sides, and then C is the hypotenuse. So in your problem, 6 and 12 are the legs, they're A and B. You're trying to find the hypotenuse, which is D. And the relationship is A squared plus B squared equals C squared. So there's kind of three formulas that we've learned today. There's the midpoint, the distance, and now the Pythagorean. So your A in your problem is 6 squared, plus your B is 12 squared. This is A and this is B, equals D squared, because your C is D this time. So 6 squared is 36, 12 squared is 144, 36 plus 144 is 180. And if you take the square root of both sides, you get D equals the square root of 180. And we'll put that into a calculator. Get 13.4.
Okay.
Now, I may have found from corner pocket to corner pocket. Okay. The next question probably asks for, I think, is 11 or the last question?
Yeah, weapons awesome.
Okay. Dash corner pocket to side pocket. So 11, 11 is asking for the distance from corner to side pocket. So the triangle, this is still 6. And then if it goes halfway up the side pocket, the whole length is 12, but this is half of that, so it's 6. So this is your A, this is your B, and this is your C. So A squared plus B squared equals C squared. Your A is 6, your B is 6, and your C is what you're trying to find. 36 plus 36 equals C squared. So 72 equals C squared. C is equal to the square root of 72. I apologize if it seems like I'm rushing. It's because I want to make sure you get this problem in before our time is over. The square root of 72 is 8.5. All right, so I'm going to send this to you as a PDF right now, since we're done with the lesson. Before we go, I just want to remind you that I'm doing a virtual homework help on Mondays and Wednesdays, and if you need just like a really quick question answered on a homework assignment, I'd be happy to help you out instead of getting a full lesson. But that's here.
Okay.
So there's one tomorrow at 4. It's totally free, and of course you know how to get to the private tutoring because you've already done that tonight. So I'm going to send you this as a PDF, and I'm also going to send you the video by email or somehow get you connected to that. I'm still working through some of that. I appreciate you um, using my service tonight, and I hope you got something out of it.
Okay. Yeah.
All right, thank you,
All
and
right.
talk to you next
Thank
time.
you.
You're welcome. Bye now.
Okay, bye.